Now, we have to find the sum to n terms by converting a non-geometric series into a geometric series. So, the sum to n terms of this series. Now, what we have to do here is, you can see that this is not a geometric series because 33 divided by 3 is equal to 11. But 333 divided by 33 is not equal to 11. So, how do we approach this question? Well, we have to find the sum of n terms, so Sn, of this series. First of all, we'll divide the whole series by 3. So 3 into 1 is 3, so 3 into 11 is 33, 3 into 111 is 333, and so forth till n terms. So now we have this series. But again, this is not a geometric series. So what we'll do now is we'll approach the question like this. Basically, 9 into 1 by 3 is equal to 3. So we'll now replace this 3 by 1 by 3 into 9. We'll take the 1 by 3 common outside and we'll multiply this 9 by this series. So this now becomes a new series, which is this series, and it goes on till n terms. But again, this is not a geometric series. So what we'll do is we'll write down 9 as 10 minus 1, 99 as 100 minus 1, 999 as 1000 minus 1. So basically this goes on till n terms. 10 minus 1, 100 minus 1, 1000 minus 1, 10,000 minus 1, 100,000 minus 1, and so forth. So this is the new series. Now it may be confusing why we have done this, but bear with me, because now we can distribute this series into two different series. This series, in which we take the terms with 10 to the power, so basically this 10, 100, 1000, 10,000 and so forth, into one term, and we basically write down the ones in another series. And since they are being subtracted, we will have a subtraction sign in the middle. So this is just a series of ones that goes on till n times. So when you add up these ones n times, it just gives you n. And this series now is a geometric series because the common ratio is 10. In the original question, there was no common ratio. Now we have a common ratio. So now what we'll do is we'll basically treat this series, the sum of this series, as n, and we'll apply the sum till n terms, the Sn formula, for the absolute value of r is greater than 1 because it's 10. The absolute value of r here is 10. So we'll apply that formula here. And so once you've done that, this is what you'll get. This is what we had to find. A formula to find the sum to n terms of the original series given to us.